Okay, guys, so we are here again in order to do this equilibrium 3D, but with two bodies. That is a composite 3D equilibrium problem. Okay. Hmm. Okay, so we're gonna start here by reading what they're asking you to get. Look, find all the forces that act on the bar AC. AC. So this is just one bar, but you have overall two bars over here. They are connected here at C, so that's why it's a composite problem. Let's just see what you have at A. It says that A, C, and D, A, C, and D, it's a ball and sockets joints, okay? So it's like a pin support, but in 3D. So you will have three unknowns in each one of those, okay? So if you try to do this globally, so what I mean by globally, okay, which one's gonna be? So globally speaking, if you wanna do, you have three unknowns here, okay? So here, here, and there. So three unknowns. Later I will try to do. Don't think I'm gonna do this mess. You have another one which is called TBE, and you have another one here which is this one, the X, the Y, and DC. Okay, so if you have this, you know that you have 7 unknowns with 6 possible equations. So now you know that you cannot solve this stuff. You need to break it apart. Okay, so that's what I'm gonna do here. I'm gonna erase what I have done and make myself some room in order to get this. But you already know this stuff. One more thing. What about the weight? Each bar weights this amount, okay? Every meter you step into the bar, it will add 200 newtons to the weight, okay? That is something that you need to take into account. So this guy measures overall 6 meters, and this guy over here, hopefully you find that 4, 3, so the hypotenuse should be 5 meters. Therefore, you're gonna have something here which is 5 times 200. But we're gonna do this stuff later, okay? But let me just now just make myself a little bit of room. So sorry, maybe that's too much. Maybe I can do it like that. And here I'm gonna do this. And so what I wanted to show you globally is that I cannot solve this stuff by just doing the overall problem. I need to break it apart. So maybe you will see, oh my God, it's gonna be a long problem. Well, yeah, maybe it's gonna be a long problem, but the thing is that you can actually solve it. So let's just go ahead and do it. Let's just start for the bar AC. Let me just put the bar AC. So I'm gonna, I was trying to make myself some room over here. And sorry to challenge your sight by looking at this, but then I will put what is important. So from here to there, you will see that I have here, this is the bar A, B, okay, so you have B and you have C over there. Let's just put the unknowns already. So this thing is AC, okay? So this thing over here is AX, got it. And this thing over there, it's gonna be AY, good. Those are your three unknowns. Here you have something that you don't know, which is TBE, that's the cable, but you have something that you already know, that's 1200, which is 6 meters times 200. Therefore, you will put right in the middle because that's the center of gravity of the bar, 1200. Let's just go at C. It says that C is a ball and socket joint. Therefore, you need to have your CY going here. You will have your C, this is your CY. This is not your CY. This is your CX. Okay, so CX. I just can't find the right component. And this thing should be right now CX. Oh my God, I said that right. So after this, what you will have over here is X. What are you doing? I'm just going right on into the problem because maybe you see it, but these are 7 unknowns with 6 equations. So I won't be able to solve it, but this is just the first step in order to do that. So if I do that, I will have that AX going positive plus CX plus the TBE part just going at X should be equal to 0. Then I need to deal with this part, but so far that's what I got. That's what I got. So AY, for the Y part, AY plus CY plus TBE, the Y part, and that's it. Yeah, that's it, equals to 0. Now let's just go with C. Well, C means that I'm gonna have AC going up plus CC going up plus the TBE. I don't know if actually this rope is going up, but I'm just putting like that, and then I will put what is actually the components. So TBEZ equals to this thing equals to 1200 because this 1200 is going to be negative here, but here it is not that negative, okay? So I have that. Boom, I have solved that. Now, let me go to do one thing before I should do that. Well, I should have done it before, but let's just go to that. I want to know what are these components, okay? I want to know those components. So the components needs, if I want to get them, I need to walk from B to E, and that walking should be, maybe you see here, whoops, maybe you see here, what's that walking? Oops, come on, yeah, there. So that walking should be a -2, okay? So I need to go back -2. I need to go back in the y direction -3, and this thing is gonna be 2 up. So thank you for the drawing. Now I can put BE. Now I can put BE as the magnitude as being 17 inside a square root. Therefore, TBE all around this. Already I'm going to put -2 square root of 17. This is the unit vector times the magnitude, TBE, comma, -3 square root of 17, TBE, comma, and 2 square root of 17 and TBE. Okay, yeah, okie dokie. Now I can put those things over there. Should I put it? Yeah, I think I'm going to do it. Okay, so you know how I got this stuff. Now that I got the components, I'm gonna use them. So yeah, luckily for us, we can just put that part and be done with it. So what I will have over here, it's a -2 TBE, the square root of 17, okay? Can I just amplify a little bit so it's easier for me? So -3 TBE, square root of 17, and this guy was a +2 TBE square root of 17. Let me just check it because I have it on my notes. So I'm not wrong, because if I'm wrong, then everything is wrong, and you know what happens. Frustration comes in and blah, blah, blah. You wanna do all over, but it's not necessary. Now, this is just my first set of equations, 1 and 2 and 3. And I'm gonna repeat those, this counting of equations because I'm gonna need them. Now, what I need to do is moment regarding something. So I'm gonna do moment regarding A. I think I'm gonna do moment regarding A. So if I'm gonna do moment regarding A, I will get R cross the weight plus R cross the rope, TBE, plus R cross the CC plus R cross the CX, because CY will pass through A and it won't produce moment. So if I'm gonna do that, let me just go ahead and put all the battery. Let me just take this as a side note over here. Let me just do this stuff with another very interesting color. So what I'm gonna have over here is R cross W. So if I'm gonna put R cross W, so I and J and K, let me just try to put the numbers that I put over there, and hopefully we are in the right way. So what I'm gonna do here is to put, okay, so how much should I walk? I need to walk 0 and 3 and 0 because this distance from here to there is 3. So that's what I need to go there. And this is 0, 0 minus 1200, okay? If I'm gonna do that, I will have that this should be -300, 0, okay? This is the first one. Let me just go with another one, R cross TBE. So for R cross TBE, I will put, should I put it over there? I'm gonna put the equations over there. So TBE, I'm gonna put I and J and K. I need more room. I think I need more room, but you get the point. 0, 3, 0, and then I will put the, well, yeah, I'm gonna use just the components. You know, the components, this is the ones that I'm gonna put over there. So -2 square root of 17, then I'm gonna put -3 square root of 17, and then I'm gonna put 2 square root of 17. Hey, what happened to the magnitude? Well, the magnitude, I don't know if you remember rush product, but you can actually a common factor of one of the rows to put it out and you will be fine. So what I will have over here, let me just not make any mistakes, TBE, the square root of 17. And if you see a mistake, please put it in the comment section. So TBE, so I can put a note within the video. So I will have that, okay? I think that's what's actually happening. Then what else? So I'm gonna go make myself some room over here. I already have this, I already have this. Let me just try with this R cross C. So R cross C, C. If I'm gonna use R cross C, C, I'm gonna have NJ, I, J, and K. And I'm gonna put, okay, so how much? Now from here to there, instead of 3, I'm gonna need to walk 0, 6, 0. Okay, all the bar from A to C. So that means that I will have CC, it's gonna be 0, 0, and CC. If I have that, I will put, let me just do this in the right way. This is CC positive. Yeah, I need to check all this stuff because, you know, one mistake just blew everything up. And R cross CX, yeah, because CY won't produce moment, I will put I and J and K, you know, the same walking 0, 6, O, and this is gonna be CX 0, 0. After this, what I will have is say, let me just do it and just check it, nothing here. For the J part, nothing. And for the K parts, minus C, CX. Well, okay, so I'm gonna put the equations. I think I have enough room to put them here. I'm gonna, yeah, try to do that. So I'm gonna put it over here. So the equations the moment at X. So the moment at X, I will put minus 3600, okay, minus 3600 plus 60B, oops, E square root of 17. Okay, so let's just raise it a little bit, and I will put this 60BE square root of 17. This fell over here, plus 6CC equals to 0. Can I make myself? Yeah, I have more room. Oops, I have more room over there. Now, this is for equation 4. Let's just go with moment at y. So if I put moment at y, I will put what? So 0, 0, 0, 0. Oh my God, such a useful equation. 0 equals to 0, and this is my equation 5. Now let's just go with moment regarding C. What I will put at moment regarding C is 0, something. So let's something TBE, square root of 17. Here, this one, 0 and minus C, CX, which is equals to 0, this stuff, okay? So yeah, so 5 and then 6. Okay, what have you done? What I have done is to analyze this individual A, B, C bar. That's what I have done. And these are my equations, 7 unknowns, 6 equations. Now, what I'm gonna do is I'm gonna put another page, okay? So let's just put another page. Hopefully that's the thing, okay? And I'm gonna put the other part. So I'm gonna put the other part. The other part was, okay, just go back. I'm gonna analyze this guy over here. So that's what I'm gonna do. And then I'm gonna reunite all the stuff that I know. So this is the bar that I'm looking for. This is the C, yeah. This is from here to there, this is dy, and this is dx. Got it. You remember that it was 8,000 going down because that's 5, the measure of this hypotenuse, 5 times the 200 for every meter that I put. Now here, this is C. So what I'm gonna put over there are the C ones, but backwards, that was the usual stuff to be put. So therefore, this is minus, well, not minus, but this is CY going there. I'm gonna put CC going like that, and CX maybe, no, here. So this one is CX. Okay, thank you. What I have from there, I'm gonna put the equation. So X, for X, I will put minus CX plus DX equals to 0. Therefore, I can put that DX equals to CX, and maybe that's somehow helpful. And then let's just put y part, the y part. This is minus cy plus dy equals to 0. Therefore, you will see, yeah, I think I have all the information. I thought I was missing something. So dy equals to cy. Okay, so something more. Now z part. The c part says that minus cc plus dc going up equals to 1,000. Okay, hopefully you agree with that. Now let's just do the moment. Okay, so I'm gonna put, oh, okay, but first 7, 8, and 9. There's a lot of stuff to be put over there. And when I'm gonna leave this space to put all the other equations. Actually, I'm gonna put all the other stuff later here. Okay, all the equations in just one way. Let's just go here. So if I'm gonna do that, I'm gonna put here the equation. Moment regarding whichever, maybe it's t or maybe it's c, whichever. So what I did here was to use moment at d. So moment at d equals to 0, and what I'm gonna put is r cross the w, okay, plus r cross cx plus r cross, right, cross, whoops, cross, yeah, cross, that's what I wanna put, plus cy plus r cross cc. And I think I have them all, yeah. So this thing should be equals to 0. Okay, so let's just do our stuff, you know, I and j and k. And what I will put is, now this is a little bit tricky, but remember that this was a 4. Remember that this guy was a 3. So this is a 3. This thing is a 4. So this point over here at G, you know, is G of the center of gravity, needs to be at the middle of this 3 and at the middle of this 4. So the 4, it's going to be a 2. That's what I need to move. I need to move just 2. From here to there, it's a 2 meter, okay, in the x direction. I don't move myself nothing at y. And I need to go down minus 3 divided by 2, which is minus half of 3. Yeah, so the 1,000, so 0, 0 minus 1,000. So from here I will get, I'm going to check it later, from here is 0. J part is minus 2,000, but it's a plus, so it's plus 2,000 and a 0. Okay, so let's just go with the other one, r cross cx. For r cross cx, I need to check it because, again, I'm so insecure. So RCX is going to be I and J and K. Now, how much should I move myself from D till I found this point C? Well, maybe you know, but this is nothing at Y, okay? Something at X, which is a big 4, okay? All these 4, and I need to go down 3, minus 3. Therefore, what I have from here is the what? Is the what? What do I have? Now the Cx, I'm doing Cx, so it's gonna be Cx, oh sorry, it's minus Cx according to this stuff. It's a minus Cx, okay? It's going, oops, well, this is wrong. Yeah, this is wrong. I mean, this is right over here, but this part is wrong. Ooh, the arrow should be pointing inside, right? Okay. A lot of details here. So minus Cx, this one is actually down, this one is, yeah, opposite, and this guy was put in the wrong way, but now we have put it right. I hopefully, yeah, this one is right, that I put over here was right. Now minus Cx, 0, 0, so what I will get from here is actually this vector, what this vector is 0, and then the j part is 0, but then minus 3x is gonna be a minus, but then it's j, so it's a plus 3cx, but let me just check it because I already have it. Yeah, I'm fine, and this guy is 0. What else? Well, let's just go with the other one. So can I put it over here? Well, I think I had some room over there. Let's just put r cross cy, r cross cy. So you will put I, the j, k, you know, the stuff, 4, o, minus 3, and then I will put what? Cy, no, minus cy, yeah, because going the other way around, 0. And then I will put over here the vector, which is something, okay? So this something needs to be a minus 3cy. Let me just check it. Yeah, so it seems that I'm wrong. So from here to there, it should be, what I'm doing? I, right? So I'm doing I. I'm doing I. Come on, buddy. Well, okay, let me just get for the J part 0 and 0, so 0. And for the K part, something. This something should be minus 4cy. Okay. Now let me just check it. Am I wrong here? Here is 0. You don't change it, but here is plus. But you need to change it, right? This is minus 3. This is minus cy. Well, I'm wrong. Okay, I'm wrong. So I'm okay. I'm wrong in my notes. I have put this guy as a plus over here. Well, okay, let's just see how that turns out. So R cross C, I'm on my own right now. So R C C, I'm actually depending on what you comment on the comment section in order to be right. So I and J and K for O minus 3. Then I will put the 0, 0 minus CC. And what you will have over here is what? 0 there. J bar is minus, but then it's a J, so it's a plus for CC. And then for the K part, you will have 0. Okay, so we're done there. And so what should we do here? Okay, so I'm gonna write the other equations for moment at x. For moment at x, I will have 0, 0, this and this. So I would put minus 3y equals to 0. Therefore, cy equals to 0. Right now, I'm just putting one of the ones that I know. And this is equation 10, okay? Now, moment at y. So moment at y, I will put the 2000. So it's 2000 plus 3cx plus 0 plus 4 plus 4cc equals to 0. And this is equation 11. And moment at c, it's going to be what? It's going to be, you're going to be what? You're going to be z, 0, 0. Okay, so look, take a look at that. This one equals to 0. Well, this was good information, but this one is not that much. So see why this is what my 12th equation says. Now, this is just a matter of solving this stuff, okay? Now, what I can say from here is this. Maybe I can make myself some room. Okay, so where should we start? Something like that. Let me just do, yeah, that's what I'm gonna do. So I'm gonna put here this, I'm gonna go back to this place. I'm gonna choose this part. I'm gonna choose this part from here, there, there. So what I will do over there is to copy and then bring it over here. So here I'm gonna just paste. So I have it over there. Yeah, can I just put a little bit like that? So those are my first 6 equations. And you will see that I have all these guys here. So I'm gonna do that thing all over again. All over again, yeah, all over again. And if this thing goes wrong, oh, I think this, let me just, and if this thing goes wrong, well, it was all in the name of science. Is what you should say. Everything is, okay, this is what I'm trying to do. I don't know if that's gonna fit or not. Okay, there. Okay, can we read this a little bit? Well, what I want to put is, so I can just, oops. This is what I wanted to put. Well, they are not on scale, but at least something like that, okay? So I'm gonna make myself some room in order to solve it. Okay, so what I want is to solve them numerically. Well, let's just see what we have here, because I already solved it over there, but I want to risk myself, in order to solve it again. Let's just choose another ink color. Well, okay, now we already have some previous values known, okay? Now from here, I can say that, well, fine. So Cx, I don't know. Cy equals to 0 and Cc, I don't know yet, okay? Now, let's just go with D. Let's just go with dx. Well, dx equals to cx. Well, I don't know yet. Now, dy, it's going to be equals to, I think I got it because from here, I know that this guy should be 0. Therefore, dy equals to 0. And therefore, here, dc, I don't know yet. Okay, then it's going to be the other ones, which are AX and AY and AC. Let's just see how that goes. But it's just, right now, just numerical stuff. And let's just not forget about TBE. This fell over there, which seems to be important. And what else? Well, I don't know. Maybe I can make myself C, D, A. What else? So let's just go to the figure, C, D. The other one was A. I think we got it, right? I think it's all. Yeah, those are our 10 unknowns. Okay, so fine. Let's just make ourselves some room here. How do we solve this stuff? Okay, what I'm gonna do here is that what should I get? Let me just do this. I'm gonna grab 4 and 6. Okay, so I'm gonna grab these two. And I'm gonna say, okay, what I want to do is to just get rid of the TVE, and they are sharing the coefficient. So what I'm gonna do here is, maybe you see this 6 TVE, okay, square root of 17 plus 6cc, okay, equals to 3,600, still 4. And this one is 6 TVE square root of 17. Now I'm writing the 6th equation, minus 6 C6 equals to 0, according to what I see. Now I can multiply this by minus, okay, and add them up. That's what I'm gonna do. Or I just can subtract both of them. These two guys will just go, and this thing will get me 6cc, okay, this guy stays positive, and this guy becomes positive, 666 equals to the 3,600. So I can simplify this, I can simplify to cc plus cx equals to 600, which I'm gonna call 13. Maybe I don't need to do that, but let me just do that. I don't know if I'm gonna use this 13 for something, but at least it's an approach, okay? After this, I'm gonna go back to which one do I need? Okay, so take a look at this one. I'm gonna join it with 11. So maybe I can write this 4cc plus 3cx, okay, equals to the minus 2000, which is the equation 11. So at least these numbers of the equations that you know what the hell I'm doing. Now I'm going to multiply this by 4, or I would say minus 4. Okay, all these things by minus 4. Okay, so I'm going to go, and these guys, and I will add them up. And if I do that, these guys will go. So this just goes, I'm not going to put it, but it stays minus 4cx plus 3cx, okay, this one here. And in this right-hand side of the equation, I will got minus the 2400, okay, minus 2000. So what I have here is that minus cx equals to minus 24,400. Therefore, cx equals to 400 positive. Okay, so what I'm gonna put over here is that I already know you and you're like that. Well, maybe after that, I already can do this for dx. So it's the same stuff, okay? Good. What else? What about DC? Do I know DC? Okay, but look at it. I already have CX, so I can go back to 6. I can already go back to 6 and try to finish that one up, okay? So that's what I'm gonna do. So if I put that thing there, I will have minus 6 TBE, square root of 17, oops, minus 6 times the 4400, horrible, but that's the way it is. The 6 just goes out. I'm dividing everything by 6, so I will get that. What I will have over here is that this guy goes all that way there. Something is wrong. Yeah, this guy was a minus. This guy was a plus. Okay, so here this one is a plus. Oh, let's just do it right. We are just going to end, but we should be plus, okay? So if that happens, this one goes all this way as positive. Therefore, I will have a positive TBE, which I was looking at positive because that thing is a cable. So I'm thinking this guy actually pulls instead of pushing. So 4400 square root of 17. You know, I hate the decimals. So I already have it over there. You know, it's newtons. Okay, so newtons, you can put it. So therefore I have 4400 square root of 17, big boom bam. So you already have it over there. Fine, what else? Okay, so it seems, what about DC? Do I know DC from here? I have CC. Well, actually I can get CC. So let's just get CC from here. Since I already have CX, I can go back to this place. So I'm gonna go to this place, which is 4, and it says 6TBE, I already had that one, square root of 17 plus 6CC equals to 300, right? Okay, so this guy just goes, this guy just goes, and this guy became 600. Okay, so when I'm doing that, this guy is known, so I'm gonna use it. So it will get for 400 square root of 17 divided by square root of 17 plus CC equals to 600. Therefore, I'm thinking that this guy just goes and CC is gonna be equals to 600 minus 4400. Let me just check it because I think I have it over there, the whole stuff. So CC is actually, yeah, I'm right, minus 384, minus. What does the minus mean? That wherever I put it, wherever I have put it in the drawings, it's the wrong way. Does it matter? Nope, it doesn't really matter. So I don't know why I put 0600 over there, but it's wrong. Okay, just got it. So it's gonna be minus 3800, 3800. So that's what I would put over there. And then what? What else is missing? Okay. So I have fulfilled this stuff. What about DC? Okay, so DC from 9. Let me just put it here. From 9, what I will get is that minus 3800, which is 3800, which is CC, plus DC equals to 1000. Therefore, DC, thank you. DC is actually 1000. What is this? DC 1000, and this guy goes all the way minus 300. So therefore DC, I'm gonna check it later, but so far this thing should be minus 1200. Okay, so I have it over there. DC. Fine, let's just check it. Yeah, I'm right. Oh, I'm just checking with my notes, so it's not that sure thing. You always need to check it. Okay, so what I have done is I have not used at all these equations, these little equations over there. I have not used them, but use them, okay? Try to use them, and I don't want to fill you in with all the stuff, but it needs to be like this. This thing should be 4,400. This thing should be 13,200. You can check it out, just do the math. And because this is actually not a static, so it's not that relevant. And this guy should be like this, okay? So there you go with this. One more thing, okay? So one more thing. Let me just, you already have it over there. This is actually the problem. What I'm doing is, I'm not trying to challenge your side or something, but I want to do a recap, okay? So, we have all that. Oh, come on. I don't know what happens over there, but you can go back there and see what is happening, okay? But what I want to do is just to do a brief recap. I'm going to do it with this. So after this, I have this information. This is one way to check if you're right or wrong. So this is my DC body. If I have my DC body, this is going to be like that. This is what I got, okay? And I'm putting these things in the right way. That is, if I had a minus, I should put it backwards of what I have put in the drawing. But this is one way to check whatever you have done or so far it's right or wrong. So I'm just putting all my conclusions, okay? So it's gonna be like that. This is my body, DC, but I also can put the same thing for the other body. So this is for my body, DC, but I can also do it for the other bar, which is the one that they are actually asking me something about. So A and B and C, and what I will put over there is this guy going down. So that's one good way to know if whatever you have done is right or wrong, that this thing needs to be in equilibrium, okay? So they need to be in equilibrium, otherwise all the stuff that you have done is, well, not worthless because you learned something, but you get the picture. So this is 13, 1200, and this is 3800, and finally in the x iteration I have this for 400. So in one of them, this one is actually not going up, but going like, you know, going to the wall. This guy is not going up, it's actually going to the wall. It's the rope, so it's like going there, okay? And the magnitude is this one. And here you have the weight, which is 1200 going down. Some of those parts here you can know that you are right because all of these guys are easy to follow. But when you have this rope over there, well, maybe that's a little bit more complicated, but its components will tell you if you are right or wrong in equilibrium here. Okay, so big problem. I mean, big as long problem, not that very important, but big problem, okay? So guys, see you the next time, okay? Whatever you wanna say, please put it in the comments and no problem. See you guys.